another circuit. Now we can see we have found another circuit to solve using nodal analysis, and we have to find these values for this circuit. One good thing with this circuit is that this circuit is already seen in the phasor domain form. What does it mean? It means that the values of the capacitance and the inductance, those have already been converted and shown in the form of the phasor form. You see J100, J100, J50. So we can simply solve it. We have to find out the values for this node voltage, and then we have to find the current values in the different branches. So let's apply the KCL at node VC. Applying KCL at node VC of t. VC of t minus Vs of t, this voltage minus this voltage divided by the impedance in this, which is 50 ohm plus J100 plus Vc of t divided by minus J50 plus Vc of t divided by 50 plus J100 is equal to 0. We can see we have three components of the current. Now we have to just simplify it. Again, 1 over 50 plus J100, this one, plus, or we can also show it minus 1 over J50 plus 1 over 50 plus J100 Vc of t from this one, and this one, and this is minus, which we can directly, or we first you can see this can be written as Vs of t divided by 50 plus J100 is equal to 0. And you see, if this is taken up on the other side of the equality sign, this will become positive. So this is what we have now, and now we have to simplify it. You can find the value of the Vc of t by simplifying this one, and from here we can, or first let's take the LCM here, which is 50 plus J100. We can simply notice that 50 is common in it, which we can also write as 50 into 1 plus J2. 51 the 50 plus J and 100, which means we also have this 50 included, and this is, so we have in this one we got 50 plus this is cancel, we got J minus 1 plus J2 and then plus J. Vc of t is equal to Vs into t divided by 50 plus J into 100. So simply you can see this 50 into J2, this is cancelled out with this one, and what we have is J plus J is 2J, so J minus 1 minus J2 plus J, or we can actually show these both together as 2J2 and divided by only J. So this is what we have. Vc of t is equal to Vs of t, and here what we got, this is cancelled out, so minus 1 over j into Vc of t is equal to Vs of t, or Vc of t is equal to minus j into Vs of t, and we know the value for the Vs of t is given already, minus j into minus 2 plus j. This value is here given. So plus j2 minus j square, so we have 1 plus j2 as the value for the Vc of t. After having found the value of the Vc of t at this node using nodal analysis at this node, we can find now the values which are of the currents that have to be determined now. First of all, the value of the current I1 of t is represented in this branch, and we can see that this voltage minus this voltage divided by the impedance of this will give the resistance I1 of t. So we can write it here now, Vs of t minus Vc of t divided by the total impedance of this branch, which is 50 ohm plus j 100 ohm. Similarly, you can find the value of the current I2 of t, which will be actually Vc of t divided by the impedance of this branch. Since this is ground, so the voltage across this element is Vc of t, and the impedance of this is this one, so divided by this one you get the current of this branch. Similarly, for the last branch we can find the value, and again this voltage is also the same from this point to this point. So this voltage divided by this impedance Vc of t divided by 50 plus j 100 will give us the value of the third current. You can again simplify these values now, and you will have the actually answer. V S of t is given minus 2 plus j1 minus Vc of t we have found plus j2 and divided by 50 plus j100. You can also write the value of this one, which is 1 plus j2 divided by minus j50, and this is 1 plus j2 divided by 50 plus j100. Now you can simply simplify these. This is 2 and 3 minus 3 plus j3 divided by 50 plus j100. You can actually simplify these further, and you can get the answers of the relevant currents. So actually these are, or you, other words, you can also say these are your answers. So this is how we have found all the currents and the required voltage. So this is finished. Can you listen me? Okay, so this is another circuit, and we have to find the value of this voltage, and we also have to solve it using the nodal analysis. Let's say this voltage is V1 and this voltage is V0. So you see, or you can also give this voltage the name of, okay, this, let's leave it V1. So according to the Kirchhoff's current law, V1 minus this voltage, or we can also give it a name of V source, so Vs divided by J20, the impedance between these two sources, and then V1 divided by J50, and then V1 minus V0 divided by J100. So you see this node has 3 elements connected, so we got these 3 equal to 0. And the second equation for the second node, using applying Kirchhoff's current law at this node, will give us V0 minus V1 divided by J100 plus V0 divided by 200 ohms is equal to 0. So you have these 2 equations, and you have to solve these 2 equations, and you have 2 variables to find, which are V1 and V0. So from V1 you can see, from equation 1 over J20 plus 1 over J50 plus 1 over J100 into V1 and minus 1 over J100 into V0, this one, and this one now minus 1 over J20 into Vs equal to 0. And obviously we can take this value to the other side, this will become positive, and now we can further simplify it, I think. So we can take the LCM here, J into hundred, so 2 5 the plus 2 plus 1 V1 minus 1 over J100 V0 is equal to, Vs is already given, that which is 120 at an angle of 0 degree, so this is J20, 8, so you have it 8 over J100 into V1 minus 1 over J100 V0 is equal to 1 over 20 J20. You can multiply both sides with J100, and that will give us 8 V1 minus V0 is equal to 5 into 120. So we have found this, and since we have to find out the value for V0, so it does not matter even if you find V1 or V0. So we can find out V1 from here, which is equal to V0 in plus 600 and divided by 8. So this is the value of V1. We can simply substitute it. Since we have found this value from equation 1, we can simply substitute this value in the equation 2, which is V0 minus V1 divided by J100 plus V0 divided by 200, and we can see now only we have V0, which is actually we have to find out. So simplifying this, 8 V naught minus 600 divided by J 800 plus V naught over 200 is equal to 0. You can multiply both sides, the whole equation with J 800, which will give us 8 minus 1 is 7 V naught minus 600 plus J into 800 into V naught over 200 is equal to 0. So this is seven V naught plus J 4 V naught minus 600 is equal to 0. And from here you can directly see, you can find the value of V naught, which is 600 divided by 7 plus J 4. So this is our answer. One very important comment that I would like to give here now, that you can use the nodal analysis 100% the same way as you use it for the DC circuits. On the same patterns you can use it for the AC circuits. For the circuits which are represented in the phasor domain form, and this is actually an important conclusion, and this is, I think we have solved enough questions, and hopefully next time we will come with a new topic. Till that time, good luck and goodbye.